Hello guys, so today we are going to discuss about lotus leaf effect. So lotus is known for its super hydrophobicity. So all of you might have seen the lotus in the usually in the dirty water, right? But the lotus leaf, or if you see the lotus flower, it will be unaffected by this particular dirt. Why? Because it will be so pure, so that the dirt will not be there, because it has got the self-cleaning property. This self-cleaning property comes based on the super hydrophobicity. Now what do you mean by super hydrophobicity? All of you know hydrophobicity, hydrophilicity. So hydrophobicity in the sense hydro hating, hydrophobic, okay, and where is water hating it is. So whereas hydrophilic in the sense water loving. So hydrophobic in the sense it is water hating property. That means it comes based in the particular lotus leaf. What happens? It has got super hydrophobicity. That means the water hating property is little bit more here. The reason the scientists, when they studied this particular the surface of this lotus leaf, they came to know that this particular leaf inside the on the surface of this particular layer, they came to know that there were micro or nano structures which were present, and these structures were the responsible for making the surface as a super hydrophobic. And that is we will study that. Depends on the contact angle, and if the contact angle is more, the droplet formation will be more, so that if the droplet forms faster, when it will fall, it will take off dirt which is present on the leaf. So that's how it is it has got self cleaning property. It doesn't mean that it is cleaning itself. It means it has got the structure in phobic to water, so hydrophobic, so that the water molecule will not sit there. They will form a bubble. I'm sorry, what do you say? They will form a drop, and then they will, while falling, they will remove the dirt which is present in this. So now the lotus, let's start with the slides. So the lotus leaf effect, also known as the lotus effect. So this effect refers to the ability of lotus leaves to repel water and self clean through their unique surface structures. Now this effect has inspired the development of super hydrophobic and self-cleaning surfaces, which have been widely used for the applications in various industry. Now wherever I don't want water to stay, I can use this particular property. For example, painting the apartments or housings or buildings, wherever, especially in the area of what do you say, in the area of when it comes to the coastal belt, for example, Goa, Mangalore, or we are having wherever we are having the coastal belt, so that because of the sea is present, so there will be humidity will be there. If the humidity is there, what happens? The water molecules will be there on the in the air, and those will sit on this particular housing building, so that they will create a kind of fungus kind of structure and all, right? So there we can have a paint where we can introduce this super hydrophobic property, crystals, nano crystals or micro crystals we can make, which will have this particular property, so that this paint, if you paint it to the building, so that they will have particular water hating property, water repellent property, so that water will not sit, so it can be used for the painting can stay for a longer duration. So, and also one more example, even for the what do you say, automobiles like cars, and even the higher end models like Mercedes and Benz and BMW companies, they are already using the painting, this super hydrophobic painting based on this particular effect, so that the water molecules will not sit on that particular the car body for a long period of time. And if any water molecules is there, and it will form the drops, and then it will clean off the dirt. So it gives both the property, super hydrophobicity and as well as self cleaning property. So the lotus leaf surface has a microscale and nanoscale structures that consist of numerous small bumps and wax coated hairs. Now this structure creates a high contact angle between the water droplets and the surface, so causing droplets to roll off and carry away any dirt or debris. Just now we explained. So this self cleaning property is due to the lotus leaf stability, or sorry, ability to repel water and as well as resist erosion. What I just explained in the introduction is written here. So this is how it looks like. You can see this is the structure, and we are having the epidermal cell microstructures. These green stuff, with green blocks, what you can see, those are the microstructures. And we are having this debris, which you can see in the green color, little bit dark green. And you can also see the wax crystals, and these are the microstructure, or even you can say the smaller structure can be the nanostructures. So these micro and nanostructures make sure that the higher contact angle, once the higher contact angle and water comes and falls on the leaf, it will form a droplet because there is no attachment. Okay, it will heat, this surface will heat the water, so it will form a drop and it will start falling it. While falling it, it takes off this particular dirt along with that. Okay, so that's how it will also act as a self-cleaning property. So the same thing, comparison, normal, this is the normal surface, and this is the lotus effect or lotus leaf surface, or any super hydrophobic thing, or if you can make by the inspiration of the lotus leaf. So same thing here, the drop, what we just saw, the droplet will take off all the dirt. But here what happens, since this substrate is not hydrophobic in nature, it is attached on the surface, so it is taking the dirt like this. So it is not going to contain this dirt along with it. Why? Because it is going slowly and it just goes like that slowly. So because since there is no much movement faster, or there is no droplet formation, it can't hold this particular contaminants or the dirt inside it, so that it will just fall off. So but it will not take this thing, so the self-cleaning property will not be there because of the lack of contact angle or less contact angle. Let's see what is contact angle and all in the next slides. So super hydrophobic and super self-cleaning property have application in industries like aerospace, automotive, building materials, and medicinal applications. Example, self-cleaning coatings can be used on the exterior buildings to reduce the need for the cleaning and maintenance, while super hydrophobic coatings can be used to prevent icing on aircraft wings. So super hydrophobic effect is a subtopic to this. So that was the introduction for this particular Lotus effect. Now we know what is Lotus effect, and major thing is we are having super hydrophobic effect and as well as the self-cleaning property. Now whatever we discussed is same thing continues here, but with some extra knowledge, that is about contact angle. So the principle of super hydrophobic surfaces goes like this. So the super hydrophobic effect refers to the ability to certain surfaces to repel the water and resist the wetting. So it should heat the water, it should take off the water so as soon as possible. Super hydrophobic surfaces are characterized by the high contact angle. So here the contact angle will be more than 150 degree. When there is a more than 150 degree, the water rolls off. So this is how it looks like. So for example, this is till 90 degree or less than 90 degree, we can expect hydrophilic surfaces, contact angle. So more than that, hydrophobic. Now how to measure this contact angle? See, now imagine this is a surface and water is falling. When you put the water on particular slides and all, if it is falling like this, if it is distributing all over the surface, then it is having a 0 degree contact angle. So more hydrophilic in nature. The surface is more hydrophilic, that means water loving. It can, next less than 90, a little bit drop will form. If the hydrophobicity is little bit more, 90 degree. If it is more than 90 degree, it starts getting the hydrophobic nature. And if it is more than 150 degree, you will achieve the super hydrophobicity. So that the droplet will form. If there is no space to stand on this, so droplet has to roll, right? So during rolling, it takes off the dirt. So that's how we will get the self-cleaning property. So now materials and examples. Now we need to make this in engineering application, artificially we need to make that. What we need to study, we need to study the surface chemistry of a materials and as well as the structures to achieve extremely high water repellency or super hydrophobicity. So several materials and coating techniques are used to prepare super hydrophobic surfaces. Here some of the examples are there. We are having the fluoropolymers, silica based nanoparticles, carbon based materials, metal based materials, polymer based materials, natural materials, and hybrid materials. So usually it comes under the material science, whereas nano materials plays a very important role. So techniques used, so there are a lot of techniques are used. You can say to prepare the material, to modify the surface and or the structure or chemistry of the materials, okay, and make sure that to get the water repellent property. Okay, so some of the examples are there: CVD, that is chemical vapor deposition. This is also a deposition technique where you are having a substrate and you will be keep on heating it so that the molecules will be evaporated and it will go and sit on the cold flinch, and that can be removed later and it will form a layer. So next, sol gel method will be there, so where the solution will be converted into the gel form and followed by the nanoparticles. Then those nanoparticles can be used for the coating purpose. Next, we are having the electrochemical methods by using the anode and cathode, and then there will be emission, and then the deposition kind of stuff will be there. Next, plasma treatment, and same thing goes for micro and nanostructural techniques like photolithography. Lithography techniques you might have already studied for IC preparation and all the similar way. Next, laser ablation, where laser beam will be given. Nanosphere lithography, where the nanosphere lithography which will be focused on this particular size. And next, electron spinning will be there, so where the electron spinning can be used so that the deposition will be there. And then finally, chemical modification of the surface. So engineering application, it has got many applications in electronics, automotive industry, aerospace industry, and even as I discussed about the housing industry. So electronics industry, you can have for example super hydrophobic coatings on circuit boards, connectors, or wherever you don't want water to be there or moisture to be there, you can use. Same thing goes for moisture resistance also. Next, self cleaning properties we discussed so far, you can just write it like that. Okay, automotive industry, anti-fog windows and mirrors, self cleaning surfaces, fuel efficiency. So fuel efficiency we can separately discuss, that is super hydrophobic coatings can reduce drag and frictionless resistance on vehicle surfaces. How? Leading to improve the aerodynamics property. So because of the aerodynamics property, and so what happens, we can also say the increase the fuel efficiency. By minimizing water adhesion, what happens, the coating helps to reduce the accumulation of water droplets on the vehicle's exterior part, so decreasing the drag and and optimizing the performance. That's how it will help in gaining the better fuel efficiency. Next, aerospace industry, anti-icing and de-icing, that is very important for the wings and components and the sensors. And then drag reduction, obviously the drag is very important, that should be reduced so that we can increase the efficiency of the flight and the fuel efficiency. Corrosion resistance, obviously wherever corrosion happens because of the moisture, so if the moisture is avoided by this particular coating, we can avoid the corrosion this thing. So next, self cleaning property, as we discussed, so that cleans about themselves, that is called as self cleaning property. So super hydrophobic nature is there, high contact angle, again it is same thing, debris and it will take it off. Principle also same, the reduction of surface energy and the modification of surface structure, because by doing so we can have the hydrophobicity so that it can take off the dirt. Next, here are some of the breakdown principle. First, low surface energy. Because of the low surface energy, what happens, that means reduced affinity of liquid or solid particles, so that means there is no much contact with them. Next, Lotus effect, we discussed that, micro and nanostructure surface, because of these structures present in that, so it is very they are hydrophobic in nature, and that also we saw in the diagram picturization in the Lotus effect. External factors, for example UV radiations, that can activate the photocatalytic reactions on certain surfaces, breaking down organic matter and enhancing the self-cleaning properties. So materials and examples are used as photocatalytic coatings, super hydrophobic coatings, self-cleaning glass, oleophobic coatings. Oleophobic coatings, wherever we doesn't want the greasy structures, we can go for oleophobic. So micro or nanostructure surfaces, which will give you the super hydrophobicity, and eventually self-cleaning fabrics. So applications, architecture and buildings, as discussed, solar panels, very important nowadays. There is a lot of moisture sitting, lot of dirt will be there. So because of that, solar absorption, light absorption will not be there. Next, automotive industry, electronics, textile, medical equipment, kitchen and bathroom surfaces, outdoor signatures and billboards, air conditioning and ventilation systems, food and beverage industry. So that's it. The next topic we will discuss in the next class.